all of you. So let us start our lecture today. So in this lecture, let's start with the revision whatever we have done so far in the case of decision tree class. Let us first revise and we'll start with our today's discussion, right? So just a minute. I hope my screen is also visible to everyone, right? The screen is also visible. Can everyone see the dashboard which I have created? Yes or no? Okay, voice is breaking a little. Okay. Okay. Is it clear now? Is the voice clear now? Okay. So let us start with today's discussion. In the previous lecture, we had discussed about. Okay, I'll share the PDF once the topic is over by today or by next lecture. I'll share the PDF whatever we have done so far, right? Okay, fine. So let us start today's discussion. So in the previous lecture, we had discussed about decision tree classifier. In the case of decision tree classifier, we discussed some of the attribute selection methods. We discussed about CART algorithm, in which we were using Gini index as a measure to perform the attribute selection operation, and we also saw the overfitting problem in decision tree classifier and some of the methods to overcome the overfitting problem. So some of the methods that we discussed was and anybody recall any of the names that we discussed in the previous lecture for overcoming the overfitting problem in decision tree? Any name or anything? Any idea? Yes, rule-based pruning was one. Pessimistic pruning, yes, pessimistic pruning. So there is post-pruning and pre-pruning. One method that we talked about was pre-pruning method. So in pre-pruning, we were already, yes, cost complexity pruning is also one of the methods that we discussed. So these are all post-pruning methods that we have. And in pre-pruning, we can have a certain hyperparameter already set up in a decision tree classifier. Whenever we create a decision tree classifier in Python, we can set some of the hyperparameters such as maximum depth that the tree can have or maximum number of leaf node that a tree can have. All these measures we can estimate and we can pre-prune the decision tree, right? Okay. So after performing this discussion, today we are going to start our discussion on regression tree. So far, our discussion has been about classification tree. So you already know what is the difference between classification and regression, right? So classification is all about classifying in a particular label that we have, right? Just a minute. So in classification problem that we had discussed so far, the classification problem we were estimating the leaf was actually containing labels, right? The label name that, for example, yes or no, or in other cases there could be other. Just a minute. So in other cases, the leaf node can have. So today we are going to discuss about regression tree, which is in regression tree, our leaf node will have continuous values. Okay, so you recall about regression problem. What was the regression problem? In classification problem, we were estimating class labels, but in regression problem, we will be estimating continuous values. So for one of the regression algorithm that we have already discussed in the classroom is linear regression, right? Yes or no? We have already discussed linear regression in the classroom. Okay, so battery is running low right now. Um, okay, wait for 2 minutes. I'll just come back in 2 minutes. I'll come in 2 minutes. Just 2 minutes. Hello everyone. I'll be joining in 2 minutes. Actually, there is a power cut here, so that's why the problem. I'll join in 2 minutes. Hello, am I audible? Okay, fine. So means again, let us start our discussion. First, in the decision tree classifier, so this classification, our discussion is suffice to classification type of today about regression. So what between regression and classification we already know. In regression, we are estimating continuous values, while in this classification problem, estimating class labels. Okay, that is the difference between classification and regression problem. Okay, the voice is not clear. Hello, is it clear now? Or okay, let us wait for 2 minutes. So far our discussion has been about classification based decision tree classifier. Now we'll talk about regression tree, which is another form of in decision tree classifier in the decision tree. So now is it clear? Now, Chintan, is the voice clear or still it is breaking? Okay, still it's breaking. Okay. Okay. Okay, let us do. Okay, let us do one thing. Are you free today from 4:30 to 5:30? Okay. Is there any free lecture today from 4:30 or any free slot? Do you have lab today? Okay. Okay, now is the voice clear? Still it is big. Okay. Just a minute. Hello. Now is it clear? Now is the voice coming, or still there is some issue? Okay, now it is clear. Fine. So let us start our discussion again. So we were discussing about regression tree. Okay. So far our discussion has been about classification based tree, but today we'll be talking about regression tree. So we already know what is regression. What is a regression problem? We already know. In regression, we are estimating continuous values, while in case of decision tree classifier for classification based problem, we were estimating class labels. Okay, that was the idea. So in case of regression tree, how will be our estimate? Okay, so how will be building? So we will be estimating in our leaf node. In our leaf node, there will be continuous values. Okay, instead of labels, we'll be having continuous values in your leaf node in the case of regression tree. So for example, let us consider an example first of all. Okay, just a minute. Yeah, okay, let us consider an example. For example, you are trying to estimate your based on number of hours you have studied in your exam. Before your exam, you are estimating the marks. Okay, estimating the marks. So if the data has been something like this, if the data was something like this, then you can draw a linear regression line that best fits your data. Okay, if the relation between number of hours and the marks obtained in your exam had linear relationship, then it is possible that you can solve this regression problem using linear regression. That is, it may have a linear relationship, approximate linear relationship between both the feature that you have. This is the feature that you have, and this is the marks that you are. This is the label. This is the output. Okay, target variable. Okay, but in some cases there may be certain issues with this. For example, suppose your data set is something like this. Suppose the number of hours. So here you have number of hours, and here you have marks. And suppose if your data is something like this, for example, less number of hours will give less number of marks, optimal number of hours may give more number of marks, and more number of hours may give less number of marks. So here you cannot fit a linear regression model. Here you cannot fit a linear regression model because the data is not linearly distributed. So one of the methods that you can use is you can solve this particular problem using regression tree. Okay, using regression tree. So what is the main idea behind, if you see the geometric intuition behind decision tree classifier, then geometric intuition will say that in decision tree classifier you are trying to, you are trying to draw parallel lines to the axis to divide your data. So for example, if the number of hours, and this is your marks that you have. Okay, this is the number of hours and marks that you have. So what are the decision lines that you can draw? First decision line you can draw is something like this. Okay, another decision line, maybe you can draw a decision line something like this. So this is the decision boundaries that you have created for each of the data set. Is it clear? So this is the geometric intuition behind the decision tree classifier, that you are drawing parallel lines that are parallel to the axis to divide the data set according to approximate. For example, number of hours is less than 6, then all the data set will have certain marks. And if number of hours is greater than 6, then it is possible that based on certain other parameters, for example, if a certain other parameter, it is possible that marks will be divided accordingly. Okay, is it clear? Anyone having any doubt up to this? Okay, is it clear to everyone what we are trying to discuss right now? Okay. So in this case, what we are trying to do, instead of in the case of decision tree with classification problem, our leaf node was having labels. Okay, labels of the class. So labels is yes or no label, right? That all labels were contained in the leaf node. But in case of regression problem, we'll be having the values, continuous values in our leaf node. So this continuous values will be actually the mean of these values. So mean average of these values. So for example, if you create a decision tree based on number of hours, the decision tree could be like this. For example, if the number of hours is less than 6, then average, the leaf node value will be having the average marks that a person can contain is, for example, 30. Similarly, after greater than 6, we have another feature. For example, another feature, we may use another feature to estimate, or we may, if less than 6, but greater than 7.5. Okay, if it is greater than 7.5, then it is possible that marks is still 70, approximately 70. But if it is less than 7.5, it is possible that the marks is equal to 80. So something like this, your decision tree will be created in the case of regression tree. So this leaf node will be actually average values in that particular, for that particular values. Okay, average values. So this average value will be actually placed in the leaf node. So here also overfitting problem can occur. How will overfitting occur in this case? How can overfitting occur in this case? Here also overfitting problem can occur. For example, if we create a leaf node for all the possible values, right? Yes or no? Then overfitting problem can occur in the case of decision tree, regression tree. Yes or no? Yes, decision overfitting can occur, but we can eliminate this overfitting by introducing certain restrictions. For example, one of the restrictions that you can add is number of values in the leaf node. So for example, if the mean that you are creating, for example, this mean value that you are creating, maximum value that this maximum number of elements that you will use to create this mean is 7. So if the instances are less than 7, then no further splitting will be done. No further splitting. Okay, but if the instances are greater than 7, then you can split further. That is, you can create further more splits, and you can create more data further down, more depth of decision tree classifier you can create. Okay, is it clear? This restriction we can introduce in case of overfitting in the case of regression tree. right? So everyone is clear about what we are doing in the case of regression tree. The only difference between the classification and regression tree is regression tree we are estimating continuous values, while in classification we were in the leaf node we were adding a class label, right? And we have also discussed the geometric intuition behind decision tree, which is actually drawing parallel lines to the axis to divide our data set. Also, in order to eliminate the overfitting, we can introduce certain parameters. For example, we can add a parameter that maximum number of instances in a leaf node should be greater than 7. In practical implementation, it is actually 20 to 25 values. So the mean average should be 20 to 25 values. If the number of instances are less than 20 to 25, then you have to stop splitting further the decision tree. Okay, otherwise you can continue with the splitting operation, right? So that is one thing. So now tell me about outlier. What will be the impact of outlier in the case of classification of this, in the case of classification and in the case of regression? Okay, so we have already discussed decision tree with respect to classification problem, and we have discussed, right now we discussed decision tree with respect to regression. One more thing is missing. Wait a minute, before we start with the outliers, one more thing is missing, that is how to estimate the splitting, split point. So for example, if you have a regression problem like this, where this is the number of hours and this is the marks that you are estimating, okay, and this is this form of data set that you have. Okay, this is the data set that you have. So okay, so first thing that you have in the case of classification problem, also we discussed that first thing that you have is you are estimating a splitting point. That is, in the case of classification problem, we were estimating an attribute to split the data set, right? In a similar manner, in the regression also, we have to estimate the splitting point. So here only one feature is there. So here we have only one feature, that is number of hours to estimate the marks of the student. So in this case, we have to estimate a splitting point. Okay, a splitting point has to be estimated. So in the case of regression, what is the matrix that we can use? What is the matrix? Anybody has any idea what is the matrix that we were using in the case of regression problem? Hello? Yes, MSE loss function that we were using in the case of linear regression, right? So in this case also, we'll be using another regression based matrix, right? So, okay, first of all, okay, so what we'll be doing is we'll be estimating a splitting point. We'll be estimating a splitting point, and then we'll estimate SSC error, that is sum of the square error. Sum of the square error means, for example, if we estimate a splitting point to be of 2, just an assumption that I'm making, this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, suppose I am considering 2 as a splitting point. 2 as a splitting point means I'll draw a decision tree boundary here. That is, I'll divide the data in 2 parts. The first part will be less than 2. So for example, splitting point is greater than 2. So left side will contain all the points which are less than 2. Okay, that leaf node will be there, and rest of the data will be here. So so the second leaf node will be mean of these values, mean of the remaining values. Yes or no? Mean of the remaining values, which will be here in the leaf node. Okay, so for example, considering this 2 as one of the splitting point, what I'll do, I'll calculate the SSC error, the sum of the square errors. That is, for example, this is a split point that I have estimated. So for example, I'll calculate what is the actual value minus predicted value, or predicted value minus actual value. Whatever is predicted value minus actual value, the whole square. Okay, this is what I'll estimate for each of the points. I'll estimate the SSC, and I'll get the total sum of the square errors in the regression tree created by this splitting point, that is 2. After this, I'll choose another splitting point. For example, I'll choose 3 or 4 as a splitting point, and I'll calculate what is the SSC loss in that case. So whichever whichever splitting point has the minimum SSC loss, minimum sum of the square error, that point will be chosen as the splitting point of your data set. Is it clear? And how to choose the splitting point? For example, one of the method is you can choose at a time, you can choose 2 points and take average of those points. For example, 2 and 3. So the average of 2 plus 3 by 2 is 2.5. So you can consider 2.5 as one of the splitting points and so on. So in this case, what we'll be doing, we'll take group of 2 points. For example, first 2 points, we'll take group of these 2 points. We'll estimate a splitting point. So for example, first 2 points are 2 and 3. 2 and 3 by 2 is 2.5. So this is one of the splitting point that we have. We'll calculate the SSC loss in this case, and then we'll estimate that what is the output, what is the SSC loss, and then we'll choose another 2 points as the next 2 points as for splitting to estimate the splitting point. Again, we'll take the average of these two. For example, 3 and 4 are the splitting points that we have. Then we'll calculate the average of it. For example, 3.5 is the next splitting point that we have. So we'll estimate the SSC loss in this case, and we'll go on for all the points in the data set that we have in the training set. We'll estimate the SSC loss, and whichever point has the minimum SSC loss, that point we'll consider to split our data set. Is it clear to everyone what we are trying to do? How we'll estimate the splitting point in the case of regression tree? Is this point clear to everyone? Okay, I'll repeat this point. I'll repeat. Okay. So in the case of, if you recall, in the case of linear regression, we were estimating the metrics for estimating metrics. What was the metrics? MSC loss was the metrics to estimate the error. Okay. And based on this error, we were keep on updating the values of parameters, right? That is what we were doing in the case of just a minute. Okay, so in the case of linear regression, our estimate for loss was MSC loss. But in case of regression tree, our estimate is sum of the square errors. Sum of the square errors means what? Error will be what? Error will be the predicted value minus the actual value, the whole square, right? That is our error. So what we'll do, for example, this is our data set. This is how the data set is distributed. For example, XXX. And our feature is number of hours is our feature, and we are estimating the marks of the student using the number of hours. So what we'll do, for example, our first split of the data set is this. This is the first split that we are creating based on our data set. Our split is, for example, 2.5. Okay, 2.5 hours I'm considering as our first split. So what I'll do, in the left side, I'll create a leaf node, and in the right side, I'll create a leaf node. So both of these leaf node will be average of these values, average of whatever instances that are present on left and right side of this boundary that I have created, right? So what I'll do for this particular split point, I'll estimate the SSC, that is sum of the square errors for this particular splitting point. So if for example, some of the square error for this particular point is 250. This is a value that you can get by subtracting the actual value minus the predicted value. Predicted value will be based on whatever average, whatever mean that you are creating based on these values, right? So for example, for this, I'll get as SSC value. Similarly, for another splitting point. So next splitting point I'll consider based on, I'll take next 2 points. I'll take the average of those 2 points. That will be my next splitting point, and I'll estimate the SSC loss. For this, for example, 3.5 is the next splitting point that I have. So on the left side, all the values less than 3.5 will be there, and all the instances greater than 3.5 will be on the right side. Okay. That is what my splitting point will do. So now this leaf node will contain the mean of all those instances, and this node will also contain mean of all the instances which are greater than 3.5 as the estimate. Okay. Now for this, I'll estimate an SSC loss. Okay, I'll estimate the sum of the square error for this particular splitting point, and whichever splitting point gives the minimum sum of the square error, whichever splitting point gives the minimum sum of the square error, that will be considered as your splitting point to divide your data set. Are you getting now? Is this clear what I'm trying to say? Yes, Dave? Okay, what about others? Is it clear to everyone what we are trying to do here? Any doubt? Okay, I'll go a little bit slow. So Priyank, up to this, is it clear or do I need to repeat some of the points? Okay, fine. So far what we have discussed is, we discussed that we are in regression tree, we are trying to estimate continuous values. Like we used to do, first method to solve a regression problem is linear regression, which we already discussed. But we discussed that some of the cases might not have linear relationship. Okay, so in this case, in this particular data set, for example, this particular data set is not having a linear relationship. So this cannot be solved with the help of linear regression. So we are trying to solve this particular problem with the help of a regression tree. Okay. So what will happen in regression tree? Leaf node will contain continuous values. So for example, if we are trying to split this particular data set based on number of hours, okay, number of hours is our estimate to split this particular data set. For example, I am considering a splitting point 2. Okay, number of hours 2. So for all the data set which have number of hours, for all the instances for which the number of hours is less than 2, which will be on the left side of the tree, and all the instances which have number of hours greater than 2 will be on the right side of the tree. And all these instances that in the leaf node, what will be the value that we have is the mean of all the instances. Okay, mean of all the values will be having on the left side, and mean of all the values will be on the right side. And we also discussed that SSC loss, SSC will be an estimate to check our splitting criteria. So whichever splitting point has minimum sum of the square error, that point will choose to split our data set. Okay, that is clear, right? Okay, so now I was asking that what will be the impact of outliers in the case of classification, in the case of decision tree created using classification problem and in the regression problem. So anybody want to give any idea what will be the impact of outliers in both the cases? Outliers in both the cases. In the case of classification decision tree and in the case of regression based decision tree. Okay, so I think what is okay, do you know this point that, for example, if we have outliers in the case of classification problem, it will have mostly decision tree are actually robust to outliers. If you see, they are very robust to outliers. So in the case of classification problem, there might not be much impact if there is an outlier. Okay, you know what is outlier, right? Everybody knows that what is outlier? Yes, right. Cable is right. So outlier may not much impact in the case of classification. So we can create a decision. We can create a branch for this particular outlier. So it will not have much impact in the case of classification problem. But since in the case of regression problem, what we are doing in the case of regression problem is, just a minute. In the case of regression problem, what we are doing is, in the case of the leaf node that we are creating in the case of decision tree is actually the average of values. Okay, average of values. So for example, if we have a data set like this, where we are having number of hours as our feature and marks is our target variable. Okay, marks is our target variable. Okay, so based on the hours, we are estimating the marks. So if we have any outlier in this case, so it will highly impact the average. Yes or no? So for example, 1, 2, 1, 2, 1. Okay, these are the three, 5 instances that I have. And for example, 40, 50, 60, 70, and 80. These are the marks that I have. So for suppose 2 is considered as a splitting point that I have. So for all the values which are less than 2 will be on the left side, and all the values which are greater than 2 will be on the right side. So which are less than 2 are a number of hours with value 1. Okay, so this average of these values will be on the left side, and average of rest of the values will be on the right side. Okay, right, that is the point. So in this case there will be much impact of outliers, because we are trying to estimate the average of the values. Okay, average of the values in the leaf node. So there will be much impact of outliers in the case of regression problem. Yes or no? Yes. Okay, Priyank. Okay, yes. Priyank, so outlier is actually, what is an outlier? For example, I suppose the data point differ from the given data set. Yes, table is correct. So for example, if we have most of the data set, for example, if we are estimating a salary, we are having, for example, consider this point, consider this particular example as a data set that you have. As a data set that you have, so most of the marks will be within 100 marks. Okay, within 100 marks will be most of the marks. So for example, 200 or 300 is some data point is having a value 200 or 300, or greater than that 500. So this is actually an outlier, right? Yes or no? Are you getting what an outlier is? So it will differ from usual data points. That is the outlier, right? So okay, right now I am so as I discussed, so there will be much impact of outlier in the case of um, regression tree. Yes or no? Do you agree with this? That there will be much more impact of outlier in the case of regression tree, but in the case of classification problem, there won't be much impact of outlier in the case of classification problem. So that is one point that I wanted to discuss about this outlier in the case of regression as well as classification. So everyone is clear up to this? How much impact in regression? Okay, how can you show how much in like how much impact in regression, the measure you want to show? See, okay, how it will impact in the case of regression? Okay, right. See, right now, for example, if we are considering this as a point, so there is a possibility. Okay, just let me show you through an example. Okay, so let us see. So for example, this is number of hours, and we are estimating the marks. Okay, we are estimating the marks, and these are the data points that we have. These are the data points that we have. Okay, now suppose in this data set we have an outlier. In this data set, so consider that we have an outlier. So for example, I am considering a split point as 2, and all the values which are less than 2 is on the left side, and all the points which are greater than 2, all the instances, by points I mean instances, okay, which are greater than 2 will be on the right side. Okay, now suppose consider that all the points which are greater than 2, and suppose we have another estimate here. For example, greater than 6 is another split point that we have created, and we are having, just consider this an example, further 2 leaf nodes that we have created. Okay, further 2 leaf nodes we have created. Okay, now consider, for example, if there is an outlier, so for example 40, 50 and 200. Okay, 200. So for greater than 6, suppose greater than 6, this is the greater than 6 value. Okay, the estimate is actually, for example, estimate is actually 50. Consider estimate is actually average marks that you are getting in the case of leaf value greater than 6, hours greater than 6 is average 50. And suppose you have an outlier here which is of value 200. So what will be the value here, average value you will get? What is the average value that you will get here? Can you tell me? I think 290 by 3. What should be the value? 90 something like, okay. around approximately 90. So actually it should have estimated 50 as the value, but instead it will estimate 90 as the average value. Yes or no? So that is how it will impact the impact. Are you able to see now the impact of outlier in the case of regression tree? Yes, 96. Sorry. Yes, now it is clear how it will impact the decision tree in the case of a regression problem. So is everyone clear with this? Okay. So yes, only one value will take us far from the average. That is what will happen in the case of regression problem, right? So here, if you can see, the average value should have been 50, but instead we have an outlier here, which is of 200 value. So this value will take us far from what is the average value. So we are estimating 90 here instead of 50. Okay, so that is how it will impact the in the case of regression tree. Okay. Okay, so now we'll start our discussion with ensemble learning. Okay, which is another point in the case of decision tree classifier that we have is ensemble learning. So up to this, I suppose everyone is clear up to this, whatever we have discussed today. Now we'll start with ensemble learning, which is another point that we have in the case of decision tree classifier. Okay, just a minute. All right. The if you can see, the decision tree will have high variance. Sorry. So decision tree that you are creating will have high variance. What is high variance? What do you mean by variance? High variance means? What is the meaning of high variance? Hello? Okay, everyone, what is high variance? Okay, distributed non-normally. Yes. So, for example, high variance means something like this. You can say that for each training example, suppose if you have different training samples from the subset of the training sample that you have. So, for example, if you have a training sample with n number of values, okay, training sample with n number of values. And suppose you are creating subset of this n number of values. Suppose you are creating two data sets, sub data set out of this n number of values. Then it is possible that if you create a decision tree for this and this, then two different decision tree will be created. Okay, that is the case of high variance. That is, for each training example, it will give different results. For different training example, it will give you different results. So it is possible in the case of decision tree. So decision tree will contain high variance. Okay, that is one of the problem that we have. So in order to solve this problem, in order to reduce the variance, what we can do is we can create additive models. Okay, additive models, which is actually that we are going to study in the case of ensemble learning, where we are combining multiple weak learners to create one strong learner. Okay, the main idea behind this is, for example, if we are adding multiple weak learners which have different variance, which have high variance, then the ensemble model that is created, the strong learner that is created after adding all these models, will have low variance. Okay, that is the main idea behind combining this model, that is ensemble learning. Okay, is the main idea clear? So what we are trying to do, for example, in decision tree classifier, where we have high variance problem, where different training sample might create different decision tree. Okay, so in order to reduce this variance, what we'll do, we'll create an we'll use an ensemble learning methodology, where we'll combine multiple weak learners to create a strong learner. Okay, is this clear? high deviation from mean. Okay. Yes, right. S- okay, so that is clear. So, for example, if you just normally, if you want to relate this problem to your normal life, then you can take an example of a movie review. For example, if a movie review is a mass entertainer movie, then it's possible that critics' review of that particular movie will be very bad. That is possible, right? But if you take a mass review of that particular movie, then it will be very good. For example, it will appeal you much more. Another example that you can take, for example, that was for example, there was an experiment done by one of the scientists where they were estimating the weight of an ox. Okay, weight of an ox. So for example, there are several people that are present in the mass, and they all estimated certain values. When the mean of that particular value was estimated, mean of all the values that were predicted by the mass, it was approximately near to the actual value. Okay, approximately near to the actual value. The same idea is going to be implemented in the case of ensemble learning. Okay, there will be combining multiple weak learners to create one strong learner. And what does a weak learner mean? Weak learner means something which is somewhat better than a model which is doing random guessing. Okay, model make very weak model is something which is actually doing random guessing. It is not learning anything, it is just doing random guessing. So somewhat better than this model will be a weak learner model. Okay. Okay, so what we'll be doing, we'll be combining multiple weak learners in order to create a one strong learner. And the main idea is to reduce the variance that we have in the case of decision tree classifier, reduce the variance that we are having in the case of decision tree. Is it clear now what we are trying to do in the case of ensemble learning? Yes or no? Hello? Hello? Okay, yes. So everybody is clear with the idea of ensemble learning? So we'll study what are some of the methods to combine the different learning algorithms. Okay. So what is the main idea behind ensemble learning is we are combining different weak learners to create one strong learners. So there are certain methods through which you can perform the combination. So mainly we'll be focusing on two main methods, that is bagging and boosting. These are the two methods that we'll be focusing on. Before these methods, there are other methods as well. For example, one of the method that you can use is combine different learning algorithms together. Okay, different learning algorithms. For example, different learning algorithms could be one of the methods could be SVM or for Naive Bayes, whatever we have studied so far, Naive Bayes, linear regression. Okay, so these are the different learning algorithms that we have. So what we can do, one of the method is we can combine different learning algorithms together, and then we can estimate, then we can create a one strong learner. Okay, we can create one strong learner out of it. Okay, that is one of the ways that we can do. Or another method that we have is we can create different learners and pass different training data set in each of the model, and then we can estimate, and then we can create a one strong learner. But both of these methods will have a certain drawback. So for example, in the case of this, what we are having a problem is we cannot, for example, if the training example is having approximately 100 values, and if we are creating subset of these training values, then it is possible that each of the model that is created with the training data set, for example, subset of the training data set will contain, will be having very high overfitting, and it is not a good thing to train your data set with, train your model with such minimum data set, right? So that is one of the problems that we have. In order to create multiple training samples, that will multiple training samples out of this data set, that will be one of the problem that we have. And so we'll be going to two other methods that we have, which is bagging and boosting, which is homogeneous kind of ensemble learning that we have. And homogeneous means all the learners will be similar. So in this, for example, in the bagging, we can use all the learner as decision tree. All the learners that we have is decision tree classifier. Okay. In the case of boosting, we'll be using decision tree exclusively. We'll be using decision tree, but these are homogeneous form of ensemble learning model. In the case of heterogeneous, what is the idea is different learning algorithms we can use. For example, we can use SVM, Ney, Bayes, and decision tree classifier, and combine the output of this to create a strong learner. That is what we can do in this case, right? So these are some of the methods. So in the next lecture onwards, we'll be discussing in depth about the bagging and boosting algorithm, and we'll discuss further about the ensemble learning methods. So up to this, everyone is clear what is ensemble learning? Everyone is clear about this? In the next lecture onwards, we'll discuss more in depth about this point, because right now the time is up, and also uh, okay, attendance, regarding the attendance, yes. Okay. Fine. I'll keep all present in this particular lecture. Because right now there is no electricity. There is some electricity issue. Fine. But in next lecture onwards, we'll discuss further about ensemble learning methods, which is the bagging and boosting method. But I hope that you are clear with what is ensemble learning method doing in this case, right? What is it trying to achieve? Yes or no? That is clear to everyone? Okay, fine. So I'll end the meeting now. So we'll meet in the next lecture, which is on Friday.